Let's talk about the domain of a logarithmic function. Since a logarithmic function is the inverse of an exponential function, the graph of a logarithmic function is the reflection of the exponential function across the line y equals x. So just think about, kind of a standard exponential function looks something like this. Your logarithmic function is going to be the reflection across that line y equals x. And so it's going to look something like, let me change colors here. So what's over here is going to be down here. And maybe my exponential curve is not quite right, but it'd be something like that. Okay, so think about that. Back to blue. Since the logarithmic function is the inverse of the exponential function, the domain of the logarithmic function is the range of the exponential function. So you look at the range, and that exponential function, the standard one I put here, the range is from 0, not including 0, to infinity. And the range of the logarithmic function is the domain of the exponential function. So our domain of the exponential of the logarithmic is this range. So that's going to be 0 to infinity. Likewise, the range of this function, of this exponential function, so notice it's producing values from negative infinity up to infinity. That is our domain for the exponential. Boy, it's like a tongue twister, I'm sorry. So how to identify the domain of a logarithmic function? Set up the inequality and inequality showing the argument is greater than 0. Solve for x, write the domain in the interval notation. So this is the argument, this part inside here, this x plus 3. So x plus 3 is greater than 0. Then we subtract 3. X is greater than negative 3. So it's going to go from negative 3 to infinity. Let's try the next one. We have 5 minus 2x is greater than 0. So we'll subtract the 5. Negative 2x is greater than negative 5. Divided by negative 2. X is less than, because I divided by negative, 5 halves. So I'd say negative infinity up to 5 halves, or 2.5. And that's it.